Good morning and welcome back, my dear students. Okay, now come back to our regular videos of chapter number 13. Right? What was the name of that chapter? Nucleus. Clear? What was there inside the nucleus? We have already discussed. Okay, inside the nucleus there are protons and neutrons. As we know, suppose this is nucleus, right? Inside the nucleus there are protons. It carries positive charge as well as neutrons. And we know that 99.99% or more than that mass of an atom is covered by that nucleus. Means all the protons, all the neutrons, they have a mass. Protons are positively charged. All the protons are positively charged, so there may be a Coulombian repulsive force. But then also they are living inside the nucleus. They are existing inside the nucleus, and the radius of nucleus was how much? 10 raised to minus 14 meter. Or you can say that 10 raised to minus 14 meter is 1 FM, Fermi meter. Clear? So, in that much radius, all the protons are residing. All the neutrons are residing. Why? Because of the name of our topic for today is nuclear force. So, what is its definition? The force acting between proton, neutron and neutron. Where inside the nucleus. So, it is its definition. That means, what is nuclear force? Nuclear force, the force acting inside the nucleus between proton means between two protons, two neutrons and proton and neutron is known as nuclear force. Is it okay? So it is the definition of nuclear force. Very nice, very easy. Now let us see the characteristics of that nuclear force. Okay, the topic of nuclear force is there on page number 445 and 446. 445 and 446. Okay, let us see its characteristics one by one. Proton, there must be repulsion, but then also they are residing inside the nucleus. Means this is the first characteristic. The nuclear force is strong. Nuclear force. Got it? And this nuclear force is much more greater than repel. Repel means Coulombian repulsive force. So nuclear force is much more stronger than Coulombian repulsive force. Got it? Okay. Second one, it is short range distance is very small, and that short range force, how much it is? Nearby 0.8 FM, that is Fermi-meter. Okay, 0.8 FM means it exists. That strong nuclear force exists between two protons or two neutrons or proton and neutron. And the distance between that proton and neutron must be 0.8 FM. If the distance increases, the strong nuclear force decreases and becomes zero also. This property is known as saturation property. What do you mean by saturation property? Means strong nuclear force exists between the two neighboring particles only. Neighborings means, suppose this blue chalk is our neutron. So strong nuclear force acting between these two neighbors only. Why? Because the distance between the two particles is 0.8 FM. 0.8 FM. If it is 0.8 FM, at that time binding energy per nucleon is minimum. Clear? If the distance is less than 0.8 FM, there is, if the distance is less than 0.8 FM, then there is a attractive force. Means the strong nuclear force exists up to 0.8 FM or less than 0.8 FM. But if it increases, then 0.4 FM, means distance between the two nucleon increases, then 0.8 FM, then that force must be repulsive force. Clear? So it is a short range force, means that force exists between the two neighbors, and the distance between that two neighbors must be less than 0.8 or equal to 0.8. Then only strong nuclear force exists, and that force is attractive force. If the distance increases, that is more than 0.8 FM, the force must be a repulsive. And this property is known as saturation property of nucleons. What is nucleons? Nucleon is a combined name of protons and neutrons. Okay? Mind well. Let us see its third characteristics. See, all these characteristics we are going to discuss with the help of the reference books as well as our GSCB book. Right? 1 and 2. Only 2 characteristics are there, and third characteristic is also there in our NCERT textbook, but we have to remember few more. Right? Third. See, here there is plus, 0 charge, 0 charge, means that strong nuclear force do not depend upon the charges. Means third property it is. That means nuclear force is independent on charges. Means nuclear force do not depend upon charge. Why? Because it exists between two positive charge, it exists between the chargeless particles, it exists between charged and chargeless particle. On which factor it depends? So, fourth one, that nuclear force depends upon spin. You know about what is the spin, it comes in chemistry also, right? Nuclear force is independent of charges, but it depends upon the spin of nucleons. Clear? 1, 2, 3, 4. Fifth is also there. Fifth, it is not a fundamental force. Means nuclear force is not a fundamental force like that gravitational force as well as electromagnetic force. As gravitational force and electromagnetic force, they are fundamental, and that is why they have an equation. But nuclear force is not a fundamental, so sixth, it having no equation. Bicharo. Fundamental force, nuclear force is not a fundamental force. That is why that bichara having no equation. Okay? So, it is the definition of that nuclear force. From the detail you will get from our textbook 445 to 446, and these are the characteristics of that nuclear force. 2-mark question. Write a short note on nuclear force. Just give the definition and state the characteristics in a full. Try to check for a few seconds, please. It's very hot today. Alright. Now let us see that next topic of the same chapter. Okay? And it is about radio. Radio means from where we are listening the songs? No, it is not there. Let us see about radioactivity. What is radioactivity? So, it is nothing but it is a property of Ra. Ra means radioactive elements. Now, what is radioactive elements? The elements which emit radiation emits naturally. Such elements are known as radioactive elements, and that emission radiation are of 3 types: alpha, beta and gamma. Very nice things. If you will see the figure, if you will follow the figure, you will get lots of information as well as lots of answers of their short questions. Alpha particle having positive charge, so it come out from the proton. Beta having negative charge, means it may be come out from that electrons. Why maybe? You will get the answer of that maybe in next video. Okay? And gamma is chargeless. So you can say that gamma rays are coming out from that neutrons. Got it? What is radioactive elements? That radioactive elements are of again two types. That is lighter element and heavy elements. What is lighter elements? The elements which are having atomic mass less than 30 and heavy elements atomic mass more than 170. Clear? Let us see once again. What is radioactivity? So radioactivity is nothing but it is a property of radioactive elements. What is radioactive element? The elements which emit radiation continuously and naturally. Such elements are known as radioactive elements. The radioactive elements having atomic mass less than 30, so such elements are known as lighter elements, and more than 170 are known as heavy elements. The emitted radiation consists of three kinds of rays: alpha particle, beta particle, gamma rays. Alpha coming from that proton, beta electron, maybe beta electron, and gamma from neutrons. So when alpha, beta, gamma are emitted, then obviously number of nucleus, the total number of nucleus decreases. How? Suppose any one nucleus consists of 3 protons and 3 neutrons, and from that there is emission of alpha. So alpha is emitted from proton. So here inside the nucleus the proton will decrease. That is the definition of radioactivity. Got it? Try to understand this. The change in number of nuclei, total number of nuclei, that is the change with respect to time. Got it? The total number of disintegration of nuclei because of this alpha, beta and gamma emission. Disintegration means decay. The disintegration of number of nuclei per unit time is known as radioactivity, or it is also known as a rate of disintegration, or it is also known as decay rate, and it having symbol R. Clear? So I will remove this. Now try to understand this. Due to that alpha, beta and gamma, that number of nuclei disintegrate, decay. How much number of nuclei disintegrates per unit time is known as rate of disintegration or decay rate, or it having symbol R. Clear? And you know that due to this emission, this number of nuclei R decreases. Because of that, we have to take here minus sign. So this minus sign indicates this minus sign indicates the number of nuclei decreases. Got it? And this decrease, that means minus delta n by delta t is directly proportional to n. What is n? N is nothing but initial nuclei. Got it? If you want to remove this proportionality constant, then you have to put one constant, that is minus delta n by delta t is equal to lambda. Lambda n as it is. What is lambda? Lambda is nothing but decay constant and it having unit second inverse. See, number, they do not have any kind of unit. It is now delta t, change in time, second, take second upside, it is second inverse. We know that if we are taking limit, which limit? Delta t tends to 0, then our equation becomes dn by dt is equal to minus lambda n. What is dn by dt? dn by dt is nothing but r. So you can get r is equal to minus lambda n. And what is r? R is known as radioactivity. Clear? See, it is very nice thing. And nice to see you from the board also. Ready? Once again. Fast, quickly. Decrease number of nuclei. Number of nuclei disintegrate with respect to time is known as 1, 2. They are the names. Decay rate or rate of disintegration, it having symbol R. R is nothing but radioactivity. Clear? And this decay rate or rate of disintegration is directly proportional to initial nuclei. Take minus sign here, put constant lambda and take the limit, you will get R. Clear? And this radioactivity, it having symbol R. What is R? R is equal to minus lambda n, or you can say that dn by dt is nothing but minus lambda n. In our textbook, minus sign is here, so no need to worry. So this is radioactivity and they are having two units. First is 1 BQ. BQ means becquerel, right? There is a very nice story on page number 400 and not 400 and yes, it is there on page number 446 and 47. There is a very nice story that radioactivity was invented by becquerel. How there was the invention? It was accidentally, not intentionally they are finding that radioactive elements, they are finding that radioactivity, but accidentally they have something which was observed by that becquerel, and from that the name of scientist becquerel, there is a unit of radioactivity is equal to 1 disintegration per second. So, what is the unit of that radioactivity? Now I will remove this. No need to concentrate on here. Now focus on here only. Radioactivity having first unit becquerel Means if one nuclei disintegrate in 1 second, that is known as 1 becquerel. There is one more unit, 1 Ci, curie. 1 curie is equal to 3.7 multiplied by 10 raised to 10. This integration per second. And this integration per second is also known as BQ, becquerel. Got it? Means, what is 1 curie? If 3.7 multiplied by 10 raised to 10 nuclei disintegrate in 1 second, that is known as curie. Clear? So, this was about radioactivity, property of radioactive elements. That elements emit 3 kinds of radiation coming out that from proton, electron and neutrons. Number of nuclei disintegrate per unit time. Number of nuclei disintegrate decreases because of that minus per unit time is directly proportional to n. If you want to put that proportionality, if you want to remove that proportionality sign, you have to put a constant lambda, and that constant is known as decay constant. Okay? What is this? It is nothing but radioactivity R, and it having 2 units. Have a look. Nothing to look. C is very common, but then also for a few seconds let us see. Then we will see 2 theories, which is much more important from this chapter. Let us see. Okay? First theory is nothing but exponential law of that radioactivity. From where we have to start? We have to start from the definition of decay rate. dN by dt is equal to minus lambda n. Now see properly what we are going to do. dN by n, take n here, is equal to minus lambda dt. Take integration on both the sides. So you will get dN by n is equal to minus lambda constant, it is dt. Now you have to put the limit. Initially time t is equal to 0. At that time initial nuclei are n0. After some time t, initial nuclei may be n, and math students will know very well, right? What is the answer of this? It is ln n by n0 is equal to, we know very well how to put that upper limit and lower limit. It is ln n minus ln n0. It is also can be written as ln n by n0 is equal to, now come on that side, minus lambda t, t0, upper limit lower limit, minus lambda upper limit lower limit, in between minus sign, it is minus lambda t. Here apply, use exponential law. When you are using exponential law like this, n by n0 as it is equal to e raised to exponential term minus lambda t, and from that n is equal to n e raised to minus lambda t, right? So this is the exponential law. Clear? By using exponential law, there are two more theories. First is half lifetime. Got it? What is half lifetime? Means if the number of nucleons are 100, it becomes half, means 50. Check the time. The time interval in which number of nuclei becomes half of initial. Again, the time interval in which number of nuclei become half of initial nuclei is known as half-lifetime. So, from the same equation, we can obtain what we can obtain here. What is this? N. So, number of nuclei becomes half of initial nuclei is known as half-lifetime. So, instead of T, half-lifetime having a symbol tau half. So, half-lifetime, it is nothing but tau half. How to obtain? Like this, by using this equation, means by using exponential law, n is equal to n0 e raised to minus lambda t. Check out the definition once again. The time interval in which number of undecayed nuclei, remaining nuclei, becomes half of initial nuclei, such time interval is known as tau half. So, we have replaced only these two here. Okay, n0 remains is equal to n0. Right? So, n0 will cut. Take 2 outside. So, you will get 2 inverse is equal to e raised to minus lambda tau half minus minus plus again exponential law. So, it will be ln2 is equal to lambda tau half, and from that tau half is equal to ln2 upon lambda, and you know very well ln mean natural log. You have to convert into that 10 base law, then you have to multiply by 2.303. Now it becomes log 2 divided by lambda. What is the value of log 2? 0.2010 multiply by 2.303. So you will get 0.693 divided by lambda. So it is equation of half lifetime. There is one more equation, tau is equal to 1 upon lambda. From where you are getting, it is nothing but mean lifetime. Clear? Have a look. How we will get this mean lifetime? From here, we are making the small correction only. Which correction? Let us say, by using exponential law, same equation, the time interval in which number of undecayed nuclei becomes, instead of 2, each part, the time interval in which number of undecayed nuclei becomes each part of initial, such time is known as mean lifetime. Mean lifetime, and it having symbol tau. Just replace this. So here instead of 2 there will be e. So it is e inverse. And now it is very easy. If the base is same, then you can compare the powers. Then you will get simple. What we are getting? Minus minus plus. So 1 is equal to lambda tau, not half. So from here, make a subject tau. Tau is equal to 1 upon lambda. Simple. In our textbook, it is given directly. Clear? So this is about exponential law. What was that law? N is equal to n0 e raised to minus lambda t. Half lifetime tau half is equal to 0.693 divided by lambda, and it is about mean lifetime. Okay? Today we have done 4 theories: nuclear force, exponential law, half lifetime, and mean lifetime. Clear? So best of luck for writing the PDF, writing the assignment as well as homework. Thank you.